What's up, everyone? This is LeetCode 15, threesome. So we're given an integer array nums. We have to return all the triplets that add up to 0. And this here is telling you that you can't use, that I can't be equal to j or k and j can't be equal to k for this, right? So this is just telling you can't use the same index, right? So we have to find 3 numbers that add up to 0 in this array. But we can't use the same index. For example, look at this example here. You can't use 0 plus 0 plus 0, because that does equal 0, but you're using I, j, and k on the same index. You can't do that, okay? So they have to be unique indexes that add up to 0. And additionally here, you cannot use duplicate triplets, right? So this here, for example, -1, 0, 1, that adds up to 0, right? You can't also include in your output array, let's say 0, 1, -1, right? Like, oh, let's do a different order, but using the same numbers. That doesn't work. You can't do that, right? They have to be distinct triplets, okay? So yeah, I think that's really what you have to know. You can't use the same index. They have to add up to 0. These 3 numbers in the array have to add up to 0. And you have to use triplets that are distinct in your output, okay? As you can see, these add up to 0, and these add up to 0. Okay, so a naive way to approach this problem, right, is the way most of us would approach any problem we may not know, right, is just do a brute force approach. So why don't we set, this is our I, this is our j, and for our k, let's just move along the array, and, right, this is let's check this pair, let's check this pair, let's check this pair, let's check this pair. Okay, after we're done, right, set this as our j, right? Let's check this pair. Let's check this pair. Let's check this pair. Okay. Now the problem with this is that you're adding overhead, right? Because when j was here and k was here, we checked this pair already, right? So now that j's here and we're setting k here, we're checking the same pair again, right? We're checking the same pair again. And again, in our output, we have to have distinct triplets. So how do you, if you're using this approach, how would you even make sure that they're distinct? You'd have to implement some weird logic to like look through the array and make sure this pair isn't already in it. And, you know, it just gets really messy and complicated on how you even handle checking whether they're distinct or not, right? So this brute force approach, you're adding overhead with the checking more than once. And again, you would add even more overhead, making sure whether the pairs are distinct or not, right? So you might imagine, okay, knowing that, this is probably not the best approach. So let's look at this input array. What do you notice about it? Well, you notice that it's not sorted, right? Because we have a -4 over here and a -1 over here. That's pretty strange. Why don't we sort it and see if we have any different perspective on the problem? Okay. Now we have a different input array, right? So how should we approach this problem now? Well, why don't we start at the beginning and set our I here, right? Set our I right here. And let's just set j 1 to the right of the I and k at the end of the array. Now let's check our pairs, right? -4, -1, and 2. When we add these pairs up, we're going to have 3 possible conditions, right? It's either going to be a number that is equal to 0, a number that is greater than 0, or a number that is less than 0. Okay? Those are the 3 possible conditions. So -4, -1, that gives us -5. Add 2, we get -3. Okay? Well, -3 is not equal to 0. We're looking for a 0, right? So how should we handle this problem now? Well, if we have a negative number, right? How do we make this number more positive, right? Keep in mind we sorted, right? So can't I just move this left pointer? And when I say left pointer and right pointer, the left pointer I'm referring to j, the right pointer I'm referring to k, because I is stationary as we check this, right? So if I move the left pointer or j over, right, aren't I making my numbers bigger because this is sorted? I am, right? So if we have a negative number, right, for our pair, how do we make it more positive? Well, why don't I just move the left pointer over to the right? Additionally, if I have a positive number and I want to make the pairs smaller so I can hopefully get a pair that's equal to 0, why don't I just move the right pointer to the left, right? Because if I'm moving this over to the left, I'm making my triplets, the output when I add them up, smaller, aren't I? I am, right? So this pair gives us -3, right? Well, why don't I just move this over? Same, we get the same number, -3. Move this over, okay. -4 plus 2 gives us -2. Again, a negative number, move this over. And let me just delete this just so you're not confused. Okay. -4 plus 3, right? 1 and 2 gives us 3, gives us -1. Not good. Move this over. Okay. Now, we have a problem now, right? Because we're at the same index. Okay? And again, remember, we have to have unique indexes for our pairs. So when the left pointer is not less than the right pointer, we have to basically move on. What does moving on mean? Moving on means let's shift this I over. And let's reset the left and the right pointers. Again, the left pointer, 1 to the right of I, the right pointer at the end of the array. Okay, so let's check again. -1, -1, and 2. Okay, that's pretty good, right? Because we get -2 here and a 2. That gives us 0, actually. That's pretty good, right? So why don't we add that to our output array? Okay, -1, -1, and 2. And as you can see in our example, that is one of our outputs, right? So that's pretty good. Okay. Now, we found a pair that gives us 0, right? So what do we do in this case, right? Because we know if we move the left pointer over, we're making the number bigger. So why would we want to make the number bigger? We already found a 0. And additionally, let's say this 0 was -1, right? Why would we care about this combination of triplets? Like, yeah, they're different indexes, but they're using the same numbers, right? We would be using -1, -1, and 2, but we already used it. So what should we do, right? What should we do in this case? Well, I'll tell you what we do. If we found a pair that's equal to 0, right? What we're going to do is we're going to take, we don't want to basically check this against all these because it's pointless, right? So what we're going to do is we're going to take the left pointer, move it over 1 to the right, take the right pointer, and move it 1 over to the left. Okay, now we have a completely new set of numbers that we can check. Okay, so it's pretty good. So now let's basically do -1, 0, 1. Okay, that actually equals 0. That's good. -1, 0, 1. Okay, so, and again, let's, right? -1, 0, 1. That's what we should be getting. Okay, so now we do the same thing, right? Move this over to the right, move this, right? Move this here, move this here. But now the left is less, the left is to the right of the left pointer is to the right of the right pointer, so we would break. Okay. And by the way, when we move this I every time, we need to make sure that we don't have the same number. Meaning, let's say we move I to the right. Why would we want ever to have an I that we already used? Meaning this is -1. Why do I want to move the I here and have -1 again? Because otherwise, if I do that, I'm going to recheck this pair, -1, 0, and 1. But we already found that, right? So what do you do in this case? Well, in this case, you basically just skip it, right? You basically just skip it, and you move forward. So let's not actually move the I there. Let's actually move forward again and actually skip that entirely. Right? And again, J, 1 to the right of I, K at the end. Okay, this number gives us 3, which is too big. So move this here. We have a problem, right? We need to move the I again. Right, and we have now we have a problem with J and K would be placed in the same tier. So we exit the problem and we return our output array, which is this. And that's what we expect, right? So yeah, that's kind of how we're going to handle this problem logically. There's a lot of cases we need to consider when handling these pointers, right? But we're going to do that, so don't worry about it. So let's walk through this. So first of all, what did we do the first thing? The first thing we did was sort, right? So let's sort this input array. Let's create our variable for output. Let's just return it at the end because we know we have to, whether it's empty or not. Okay, so let's iterate through this array, right? We're going to say for index num in enumerate nums. Okay. Now, if nums is greater than 0, we're going to break, right? Because, which is actually what we should have done here. That's my mistake. I made a mistake actually in showing this example. Or actually, no, I didn't, because the I was at 0. But let's say I's at 1 here. We actually wouldn't even put the J and K here. We would just break right away because imagine we have more numbers, right? Like 5, 7, like imagine this array goes on, right? When I is here at this 1, why would we want our J here and our K here? We have all positive integers. How would we ever get a 0? We would never get a 0 in this case, right? So when I's at a positive number, J is going to be at an even more positive number. K is going to be at an even more positive number. So when I's at a positive number, just break completely, right? We'll never get a 0 because we'll never get a negative number to the right of this to give us a 0. So when I's positive, just break, right? Just break. There's no point. We'll never get a 0. So that's what this is doing here, okay? And again, num here is basically the I, okay? You can call it I if you want. I'm just going to call it num. So, so we're going to say now another case we need to handle. And this is what I was showing you before, which is if we have a number, that is the same as the previous number, we need to move on, right? For example, when this I was at this -1, we found this triplet, right? Let me do a different color, actually. We found this triplet that gives us 0, right? Right? So when we move I over, why would we ever want to use the same I? Because we're just going to get the same triplet again. But instead of using this -1, we're going to use this -1. We don't want to do this. Again, our duplicate, we cannot use duplicate triplets. They have to be distinct. So if we move I over and it's at the same number, right? It's at the element is the same. We want to just skip it. We don't want to handle that, right? And that's what this is doing. So let me just comment this just so it's clear, right? If num is positive, no addition will make the number we'll make the number 0 because we are adding positive integers to positive integers. Why? Because we sorted, right? And this has to do with the fact that we put the J 1 to the right of this I and K all the way at the end of the array. And again, since it's sorted, again, we'll never add 3 numbers that add up to 0 in this case. And here, right, we basically just don't want to reuse the same I, so we can avoid duplicate triplets. Okay. Now down here is where we set the right, we don't run into any of these problems up here that are like edge cases we have to handle. So in this case, let's just set the left and the right pointer. So the left pointer went to the right of I, right? So we're going to say index +1. And again, the right pointer is at the end of the array. So we're going to say length of nums -1. Okay. And then down here is basically where I said, right? The left pointer has to be to the left pointer has to be to the left of the right pointer. And now let's handle, now in here, in this while loop, that's the stage. Holy crap, this is a mess. But basically that's this, so if I is here, right? This while loop is handling everything in here basically now that we set the pointers, right? That's what we're going to do, okay? So first of all, let's get our, we'll just call it threesome for simplicity's sake, just so we know what we're getting, right? Or what this variable means. So we have nums, and again, nums is really just the I. Now let's get the j, nums of j, right? So we're gonna say nums of L. Remember what I said earlier? This j technically is the left pointer, this k is the right pointer, right? That's, I'm using them interchangeably, but I'm referring to the same thing. And again, the right pointer, right? So this nums here, this is the I, the left pointer is this j, and the nums of r is this k, okay? So let's add those three up. And again, we have three possible conditions. I remember I told you, we're either going to get a number that's 0, greater than 0, or less than 0. So we need to handle those edge cases, okay? So if we have a number that is 0, that's awesome, right? Because we want to add that to our output array. So we're going to say append. Again, this has to be a pair. So we're going to put another parentheses. We're going to say num. That's the nums of I value. The nums of j value is nums of L. The nums of k value is nums of R, right pointer, right? So yeah, that's when it equals to 0. Remember what I said? We don't want to we don't want to make this number any bigger or any less when it's already 0. So let's just move the pointers over and make this algorithm more efficient. So move the left pointer over 1, the right pointer back 1. Okay, pretty good, right? And oh, I forgot another thing, right? This is kind of messy. I don't know how much of this I can delete. Whatever. Let's say I forgot to add this in my example. This problem has a few edge cases, kind of hard to remember all of them. Let's say I is here, right? J is here and K is here. Okay. Now, just like what I said, when our I moves over, we don't want to use the same number. That's also true for K and J. So let's say this is our, so we found a pair, right? I, J, K, right? So when I move this left pointer over, if it's the same value, I want to keep going until it's not the same value. Likewise with K, right? I want to keep going to the left until I get a value that's different, right? The reason we do that, by the way, is because let's say we have -1, right? 0, 0, 1, right? We have I, J, K, right? When I move this over 1 to the right, why would I ever want to consider this? It's a duplicate triplet, right? We don't want the same values for I, J, or K, right? So that's why we keep moving this over until we have a unique number. And again, if K, let's say this was a 1, I want to move this over until we have a different value, right? Because again, all this is just to avoid duplicate triplets. And you would maybe get a case where you keep moving I. Obviously, in this example, I'm only moving J or K because I have 4 numbers. But you could have a case where both of them, like J keeps moving to the right for a little bit, K keeps moving to the left for a little bit, you know, to readjust. Because our input could be huge. I mean, we're talking huge, right? So you could have, and obviously I can't write numbers this big, right? With these constraints on the screen. So I'm being, it's kind of a simple example, but we want to also move J and K over when we find a duplicate pair. We want to keep moving J and K until we get different values as well, not just the I. So basically what we did to the I when we move it over, and we keep doing that until we don't have the same value, we do that for J and K as well when we find a pair, okay? So here, for example, we're going to say, while nums of L is equal to nums of L plus 1, or sorry, no, nums of L minus 1, because we already moved the pointer up here, right? So while nums of L is equal to nums of L minus 1, and the left is less than the right, let's move the left pointer over. While nums of R is equal to nums of R, and again, we're moving the right pointer to the left, so we're going to say nums of R plus 1, and left is less than the right. r minus 1. Now, there's a lot of solutions to this problem. Some people don't do this. They have like a bit of a different solution, but this is just making this kind of like a perfectionist type of solution where I'm just trying to be super efficient and not handle stuff. Because like technically you could keep only moving the left pointer over, right? When you find a pair, but I'm moving both of them, right? There's a lot of solutions to this problem, but this is like the hyper efficient solution. So this is what I recommend. I think there are a few people who've done similar solutions to this, by the way, that are like quote unquote hyper efficient. But anyways, so now we did that. Okay. Now we have another case where we have a negative number. And if we have a negative number, what do we do? If we have a negative number, move the left pointer over, right? So we can make the number bigger. Right? Else, when I say number, I'm referring to threesome, obviously. If we have a positive number, we want to make it smaller, so we'd move the right pointer. Okay? And then we can return answer. Okay. Can only concatenate list, not int to list. Nums of L, nums of R. Oh, sorry. I said nums. It should be num. Nums is the array. Num is the actual number that we're on. Okay. This is our output, right? We have a little error here. So what could this be? Whoops. I just found out. So this return answer is inside this for loop. We want to make sure that's not the case. Move it outside the for loop. Silly little mistakes when you have quite a bit of code. There you go. So I will say this problem is not the easiest. It is actually quite a difficult problem. You'll see other people who've done videos on this problem say the same thing. And I agree with them. This problem is a bit tricky because there's a lot of edge cases you have to handle, right? And that's why this video is a little bit long. Again, I could have made this video a little bit shorter, but I just want to be meticulous and explain everything so you're not confused. But yeah, this is an efficient solution, but not very easy to come up with on your own. I certainly struggled with this problem. I definitely struggled with this problem when I came across it. So you're watching this video, you're in the same boat, so don't feel bad. It's okay. This problem is a bit tricky for sure. No doubt about it. But you know, hopefully, right, you can learn from it. Understand what you need to do, and you know, next time around you come across this problem, hopefully you can solve it, even if you know it takes you a little bit to kind of consider all the edge cases. But let me submit one final time. But yeah, I hope this helped. Sorry for the long video, but I'll see you in the next one. Peace out.